So let's take a look at some more examples of area functions. So here's a function, and this function, this is the graph of f of t, where f of t is t sine t, or f of x is x sine x. And we want to define this area function so that it's the integral from 0 to x underneath this curve. Okay, so that means then that this area function describes the area. It starts at 0, so I'd start here at 0. And then as I move along the x-axis, this function will give me the area underneath this curve. So sometimes we're interested in certain things about this area function, and in this particular case, the question that's being asked is how many zeros does the area function have on the interval shown? Okay, and then we're also going to just roughly show where those zeros are. Okay, so the first thing I want to point out here is that these are not the zeros. That is this 0, pi, 2 pi, and 3 pi. Those are not the zeros of a of x. Those are the zeros of our f function, which it might be something I'm interested in, but in this case it's not what I'm actually interested in. I want to know what the zeros of the area function are, not of the f function. So let's think about what this actually is asking. How many zeros are there? Okay, well, since this is our area function, it starts at 0 and it ends at x, I want to know basically what x values create an area of 0. So notice right off the bat, 0 is one of them, x equals 0, because if I find a of 0, I'd have the integral from 0 to 0 of t sine t. Now, it doesn't really matter that it's actually 0 here. The fact of the matter is that my bounds are the same, which means there's no width, which means that my area is going to be 0. So there's one already. That's kind of like the obvious one to begin with. So far, we have 1, 0. Now, what we'll think about doing is we'll think about the area under the curve as we progress forward. That is, as we increase our x values. So notice as I go forward, I'm adding area here. Okay, and as I stop at pi, I have some positive area, don't I? Okay, so what I want to do is figure out, well, how far should I go to negate this positive area? If I negate that positive area with a certain amount of negative area, that is the same amount that I have here positive, it'll end up resulting in a 0 area, which is what I'm looking for. So I'm going to keep going, and let's see when I want to stop. I want to try to create, maybe it's better if I just think about coming this way. I want to try to create the same area here as here. It looks to me like it's maybe just a little before 3 pi over 2. That is, it kind of looks to me like these two areas are equivalent. This one's positive, this one's negative, which will result in another 0 area. Now, that means at this moment in time x, the area function is 0 right there. So if I keep going forward from this point, now I have a negative area. This area from here to 2 pi would be some negative number. Again, I don't really care what that number is. What I want to do is I want to now basically undo that negative number by adding some amount of positive area here to cancel that. Now, it's definitely not going to be this entire 3 pi, right? Do you see how this positive area is much larger than this negative area that I have? So, and it looks like it's probably not even going to be quite 5 pi over 2. It's going to be a little bit before that, maybe. And of course, I'm just estimating here. I'm just eyeballing. Now, it looks like, well, maybe a little bit farther. It looks like now these two areas are roughly equivalent to each other. So there's another 0. This is a negative amount, and this is a positive amount, so these two will undo each other. So that means then that there are 3 zeros. And again, I see that there's one at 0. That's the only one that I can actually know for sure what x value it occurs at. So there's one here at 0. There's another one here, somewhere between pi and 3 pi over 2, closer to 3 pi over 2. And then there's another one just before 5 pi over 2. But that's really about as good as I can get at the moment, but I want us to at least see, kind of get an idea of when these values are going to cancel each other out. So this one has 3 zeros. Let's take a look at another example. And this is another area function. We're going to look at this in 2 different ways. Let's go ahead and say that our a of x function, again, this is my f graph here. My a of x function is going to be the area under this curve from 0 to x. and my b of x function is going to be the area under this curve from 2 to x. So let's answer a few questions about our two different area functions. Let's start off with how many zeros? And we might even be able to figure out where they occur. Okay, we might be able to get a little more accurate with this one. Let's find out. So let's start with a of x, and I just want to figure out how many zeros there are. So again, my a of x function starts at 0, which means that if I start here, here's my a of x function, notice I'd have the area, so a of 0 is going to be the area from 0 to 0 under f, and again, since these two are the same, that's going to be a 0. So far I have 1 0 for my a. So then again, we can think about adding area. All right, so in this case, as I progress forward, okay, I'm increasing my x values. Notice I'm going to have this negative area here. Okay, now I could actually figure out exactly what this area is. I'm going to go ahead and not do that just for right now, because I'm just looking for zeros. Now notice that whatever negative area I find here, the same area is going to occur from 1.5 to 3. That is, the area from 0 to 1.5 is the same as the area from 1.5 to 3, except they are opposite in sign. So that means I have another 0 at 3. Again, because if I go from 0 to 3, this negative area and this positive area are going to cancel each other out. So there's another one. I found 2 so far. Now as I keep going from 3, so I'm at 0 here, the area function would be 0 here. As I continue progressing forward, I'd have this positive area, and then notice that this negative area is going to again take away from this one. So I'm going to have another 0 at 6. Okay, so that means then that a of x has 3 zeros, at least on the interval that I'm seeing here from 0 to 6. Okay, let's think about b of x. Okay, so b of x is a little bit different because it starts at 2 instead. So let's think about what that might change. So it's going to start here at 2 instead. Now I can progress forward, but I can also progress backwards if I want to. So let's think about progressing backwards. Now notice if I progress backwards, that is if I say I go to 1, b of 1 would be the integral from 2 to 1 of f of t dt. So let's just think about what that would mean. Okay, so notice here that instead of going from 1 to 2, I'm going from 2 to 1. Now you might remember that this involves a property that generally when we have a lower bound that's larger than the upper bound, we can think about switching those. But when we do that, it ends up negating the integral. Essentially, you can think of it as this has like a negative width. Once I undo the negative width, I would basically negate it. So I can kind of think of it this way then. If I progress left, this positive area is actually going to be negative because I'm going to the left of 2. So if I went to 1.5, this area, which is going to be, let's see, 1/2, 4, 1/2, so that would end up being 1. This has an area of 1. But if I look at the integral, so b of 1.5 would be the integral from 2, it's my starting point, to 1.5, it would end up being this negative of this area, which would end up being 1. So this area would be negative 1 if my area function were starting at 2. So this kind of turns things around a little bit, because visually we're seeing this, usually we would think about this as a positive area, but because our area function starts to the right of that, it's actually end up being a negative area. So this makes things a little bit different when we're looking at zeros or when we're answering questions about this particular area function. So when I just want to find the zeros, I can still go ahead and think about negating things. So with my b function, as I progress to the left, this area would be negative 1, and then as I progress this way, this area then would be a positive 1. Because it's negative, it'd be negative, negative 1. So that means that at 1, these two are going to cancel each other out. So b of 1 equals 0, because it's going to be the integral from 2 to 1 which is going to be this negative area plus this positive area, and I'll end up getting 0. Okay, now that's again because I'm progressing backwards instead of forwards. So let's think about progressing forwards. Oh, actually I should also point out here the obvious one. B of 2 is 0 because my starting point is 2. The integral from 2 to 2 would be 0. Now we can think about going forward. That's going to be my only 0 going in the left direction. After this point, I'd end up having this positive area. I know it seems weird. It's a positive area because I'm going in the negative direction and it's below the x-axis. So there's not going to be any more zeros over here. As I progress forward this way, okay, notice this would be a positive area because I'm from 2 to 4. That's positive width, and my height is also positive. So this would be positive, positive, and notice that as I progress forward, I'm not going to be able to cancel out this entire area. These two areas cancel each other, but I'm still left with this one. So that's going to be the only zeros then. B of x has 2 zeros. Okay? So notice how big of a difference we can end up having depending on where our area function is starting. Now another thing I might want to answer about this particular area function, maybe we'll do both of them, is what the maximum and minimum are. So let's go ahead and answer that. So let's find the max and min values of both a of x and b of x. Let's go ahead and start with a of x. I think this one will probably be more intuitive for us, and then we'll go ahead and do b of x. So if I look at a of x, again this one starts at 0, a does. So I'm looking for the max and min values. Let's go ahead and start progressing forward. Okay, as I move forward, I'm going to have this negative area here, and then it's going to go from negative to positive here. That is, the function goes from negative to positive. Now that means that I'm going to go from decreasing area to increasing area. So that means then at 1.5, a of x would have a minimum. Okay, and it has a minimum because that's going to be where the smallest value occurs. I have this negative area, and then I'm going to stop, and then I'm going to start adding more area back. I'll have decreasing area to increasing area. So we'd see something like this in the area function. Decreasing area to increasing area. Okay, now as I progress forward, and actually let's continue. I want to also say the minimum is, well, it'd be whatever this area is from 0 to 1.5, which I can use geometry to find out. Well, I found out that this one was 1. Again, that's because the base is 1/2 and the height is 4. So 1/2 times 1/2 times 4, area of a triangle, is going to be 1. And then this area, I can see it has a base of 1 and a height of 4, so it has an area of 4. So that means then my area is going to be -5. It's below the x-axis. So the minimum value is going to be -5, and it occurs at x equals 1.5. Now if I look at the maximum, as we keep going, okay, now I'm going to be adding area, adding area, adding area, all the way until I get to 4.5. Because after 4.5, now I'm going to start taking area away, so we're going to see the area function change from increasing to decreasing at that point. So that means then at x equals 4.5, a of x has a max. Let's figure out what that max is. The max is going to be the integral from 0 to 4.5. And let's see. Well, the nice thing is that these two are going to cancel each other, so I can think of those as 0. And then from here to here, this has the same area that we just found, except it's positive. That is, this one's 4, and this one's 1, so it has a maximum of 5. Okay, so that's for our a value, or our a function, that is. It has a min at 1.5 and a max at 4.5. So let's go ahead and answer the same thing, but now for b of x. Okay, so again, b, my b function, starts at 2. Okay, so we're going to try to find the maximum and the minimum. Okay, so it's probably going to be that the maximum occurs when I'm going this way. But we also have this negative area that's going to end up being positive area because I'm moving to the left of my starting point. So let's go ahead and think about moving left here. As I move left, I'll end up having this area, which is going to be a -1. And then I'm going to start adding it back here because this negative area will actually be positive. So my b of x function is going to have a minimum. So at x equals 1.5, b of x is going to have a minimum value. Okay, and again, it's going to be a minimum here and not continuing because this is no longer a negative area when the b function is concerned. Where the b function is concerned, this area is positive because I'm moving to the left of that starting point. So the minimum value occurs here, and it's going to be the integral from 2 to 1.5, which in this case is going to be a -1. Okay, again, as I kept going this way, I'd end up adding area back. Okay, so let's talk about the maximum. So notice if I keep going this way, I'll end up getting an area of 4 if I go all the way to 0. But I can see already that if I, instead of going left, if I go right, I'm going to be able to get more area. If I go to the right, I'll have 4, 8, an area of 9 if I stop here. Again, this is positive area because it's above the x-axis and I'm moving to the right of that starting point. So I can see then, I don't want to move past 4.5 because then I'll start taking this area away. So at x equals 4.5, b of x has a max. And the max value is going to be the integral from 2 to 4.5, which is, like I mentioned, 9. Okay? All right, so that's my maximum and minimum values for this particular b function. So again, it really does matter where your area function starts. Notice though that a and b did have the same x-coordinate for the max and the min. And that basically means, it's basically because our f function goes from negative to positive versus positive to negative, which kind of gets back to what we had talked about in that particular section.